Is your groundwater polluted with toxic contaminants? Are you tired of consuming disgusting contaminated water? If so, you may want to try out this awesome hydrogel bead with immobilized bacteria Rhodococcus rhodochrosus ATCC 21198 and growth substrate tetrabutyl orthosilicate.
Now hold your horses. How does that work?
We've got to zoom way in to see what's happening.
For the rest of the video, we're going to be using representations of what happens in a hydrogel bead. The little orange shapes are our bacteria. The red triangles are the contaminants. The blue-green triangles are the slow-release compound, TBOS. The blue spaghetti strands are the polyvinyl alcohol, and the green spaghetti strands are the sodium alginate. Bacteria need energy to survive. When bacteria break down the growth substrate, they get energy from it, almost like eating food. As you can see, the contaminant looks just like the growth substrate. The bacteria will try to degrade it in hopes of getting energy.
The process of degrading the non-growth substrate or contaminant while getting energy from the growth substrate is called co-metabolism. Through the power of co-metabolism, these mighty bacteria are able to clean our water of contaminants. However, we need a home for them to stay in. That's where hydrogel beads come in.
What is a hydrogel? Imagine Jell-O. Jell-O can have chunks of fruit suspended within it. The bacteria are immobilized in the hydrogel, just like the fruit is immobilized in the Jell-O. Hydrogels are made up of polymers. You might be wondering, what is a polymer? Polymers are super long molecules made of repeating base units. Since polymers are so long, they can get tangled up with themselves. But you need a high enough concentration of polymers in order for them to get tangled up with each other. This concentration is called C star, and it's where the hydrogel can start to form.
The concentration of polymers here isn't high enough to form a hydrogel. This concentration is high enough. The polymers are now entangled together. However, the polymers can still slide around, which isn't solid enough to immobilize bacteria. What we need to do is lock the polymers in place. We can do this through a process called cross-linking, where ions connect polymer chains where they are tangled, locking them in place. We have two types of polymers here, sodium alginate and polyvinyl alcohol. They each need their own cross-linking ion, so we have two cross-linkers as well, calcium chloride and boric acid. This makes a structurally sound home for the bacteria.